Hello friends, I am Ram Lakshmanan. So in this talk, we are going to be discussing about simulating and troubleshooting the blocked threads in Scala application, right? So here we're going to simulate a set of how to simulate blocked threads in the Scala and how we can go about troubleshooting, right? That's what we're going to be discussing. So for our discussion, here I've put together an hypothetical Scala program. So let's look at this. So here, there is this blocked app object, and it has this main method, right, which is kind of the entry point. Here, if you see what's going on, this Scala, this main method, here it is going on a loop. It's going on a for loop, and it's going to create like kind of, it's going to go on a 10 iterations, right? It's going to do. So in each iteration, it's going to create a new app thread. Right? It's creating a new app thread. So it's going to create a 10 app threads. So that's what this main method is going to do. So what does the app thread does? Here is the code for it. Here's the app thread. If you see the run method, which is the kind of the entry point for this app thread, which gets executed when the thread starts to run, it is invoking this action method. Right? It's invoking this action method on this blocked app object. Right? This is that action method. You see, this action method is a synchronized method. What does the synchronized method does in Scala? That means if a method is synchronized, only one thread is allowed to enter this method at any point in time. So you say if multiple threads starts to come in, only one thread is allowed to enter. All other remaining threads are put into the blocked state. Right? That's what it does. But let's see, there's something interesting going on within this action method. Right, in the synchronized method. Here, this method, there's a while true. That means while true means this going to be on a true always. And within this, it's basically of infinite looping. Right, within this infinite loop, what it's saying is putting a thread to sleep for 10 minutes period. That is, if a thread comes in, if any thread comes in to the synchronized method, it's going to sleep for 10 minutes. And after sleeping for 10 minutes, when it wakes up, it's going to come on the next iteration of this while loop. Since this condition is true, it's going to come in once again, and it's going to sleep once again for 10 minutes. Basically, what it means is any thread which enters here is going to sleep infinitely. That's what it does. So if a thread which is coming in and sleeping infinitely, that means what's going to happen to other threads which wants to enter this action method? They wouldn't be able to enter. They'll be on a blocked state forever, right? So this is what happens when this program is executed. We are going to have like just one thread is able to go and execute this action method. The remaining 9 threads, they are going to be into the blocked state. That's what happens when you execute this program. Okay. So this hypothetical program, we are putting in this for infinite loop, but it can happen in real production as well. There could be some synchronized method where within the method, maybe you're making a backend call and the backend system of record is not responding to you. Circumstances, this can very well happen, right? So how do we go about troubleshooting? Say if it is because the threads is related to the blocked state, you want to capture thread dump when the application is suffering from this problem, and then you want to analyze it, right? But capturing that, you want to capture at the right point in time, and then analyzing it manually is also going to be tricky, right? You're welcome to do totally, but there is also an automated approach. So that's what we're going to be showing you briefly here. So there is this open source script called as a yCrash. So this yCrash script, when it's triggered, it's going to capture a 360-degree data from your application stack. It's going to capture 16 artifacts from your application stack. So one of the artifacts it captures is a thread dump. In fact, what is this? And once again, I want to specify this open source script, the yCrash. It captures 3 snapshots of thread dumps in a gap of 10 seconds. That's a default behavior, which you can tune it if you want, tweak it, right? So capture 3 snapshots of thread dumps, and then it presents it to you. So now you can take it and analyze it either manually, or also yCrash also provides analysis, the dashboard, and it can present you the result. So here is that analysis of the yCrash snapshot data, which was captured from the Scala application. You have seen. So all those 16 artifacts that we saw has been captured If you want to see each and every one's report here, you can click here and then see what's going on. But now since here it's showing, okay, this is a summary page, it's already pointing out this problem. Let's go to the threads, because this is where it's going to talk about, show the thread problems. See, here it is showing, okay, 9 threads are blocked. And this is the exact line of code, the method where it's blocked. So let's come in here. Here it shows this kind of a transitive dependency graph. And here I can see, okay, these are all the 9 threads which is being blocked, right? There's only one thread which is allowed to enter. And this is the thread which got inside, and then it never released the lock. So all the other 9 threads are getting stuck here. I can say, if you want to see, these are the victim threads. So if you want to see where they are getting stuck, I can just click on them. So I'm clicking on one of them. Here it shows me the stack trace. Okay, here it's saying, okay, there's a blocked app thread, and now it is trying to acquire this lock. See, it says it's waiting to lock. It hasn't got the lock. It is on this method, this action method. Because the other thread has taken, this is getting to the blocked state. It's presented to me. So let's click on some other thread stack trace. Let me click here. This is another thread, thread 1. It also has this exact same stack trace. It started with the run method. It is waiting to acquire the lock. Because the lock is taken by the other thread, it is put on this blocked state, right? So all these are victims. So this is the culprit thread which acquired the lock and it didn't release. But after acquiring the lock, it just went on an infinite loop. If you want to see what this thread is doing, I can just click here. Click here. Okay, here it says the thread started. One key thing to notice here is it says it has acquired the lock. So it says it's locked to this object. Whereas if you see the earlier stack traces, they were saying they're waiting to lock, right? They acquired the lock, and after acquiring the lock, you see it's going on infinite sleep. Right? So equipped with this information, I know exactly what are the victim threads and what is the culprit thread. Okay, I know, okay, this is what is causing the problem. Then I can go ahead and fix it. Okay? This is one effective way how we can go about troubleshooting this sort of threading related problems in Scala. Okay, so any questions, friends, on this? So, okay.
No.
Okay, so okay then. So thank you, friends. I will catch up with you in yet another interesting talk. Thank you very much.